Hello everyone, the University of Memphis Center for Information Assurance research team has developed a novel multi-factor authentication prototype. The Adaptive Multi-Factor Authentication Framework identifies authorized users through an active authentication process using passwords, biometrics, cognitive behaviors, and other factors. Authentication factors are selected adaptively by sensing the user's operating environment. This includes connected devices, communication media, and surrounding conditions. Previously selected authentication factors are also considered. The novel aspect of the invention lies in the design of an algorithm that determines the optimal modalities given the user's operating environment and previously used modalities. The A-MFA system uses both biometric and non-biometric authentication modalities. Our prototype includes keystroke, voice, face, and fingerprint biometrics, as well as the standard password and passphrase modalities. No biometric data is stored on the client device. In addition to these, out-of-band modalities such as SMS and time-based one-time passwords are supported through the use of mobile devices. The client application captures the ambient light, noise, and location to determine the user's surrounding conditions. The network information is used to determine the type of device being used, fixed or portable, and the connection type, be it Ethernet, Wi-Fi, or cellular. This information is used to differentiate between multiple connections of the same user. All of the information collected is passed to the server over a secure encrypted connection. The server will process the information and return a response directly to the client. If the SMS modality is chosen, the server sends a password to the user's registered mobile device. For the time-based one-time password, a secret is shared with the client during registration. After this point, no communication is required to be made with the phone in order to use one-time password. As a part of user statistics, each connection request is logged in the database. Raw biometric data sent by the user must pass through a feature extraction phase. The relevant features are collected and stored in a template. Only templates, never raw biometric data, are stored in the database. When a client submits an authentication request, the server will execute a selection algorithm that evaluates the user's surrounding conditions and the previously chosen set of modalities to select a new, optimal set of authentication modalities. The selected modalities are returned as a challenge to the user. After the user responds to the authentication challenge, the features are extracted from the responding biometric data. These features are matched against the target features, which are retrieved from the database. Based on the match result, the server will successfully authenticate the user or decline the attempt. This shows the overall system and how the client and server components are connected. Next, we have a demonstration of the software we have prototyped. This is the welcome screen for the Adaptive MFA system. To begin, the user is prompted to enter a valid email address. If the email address does not exist in the system, the user is prompted to begin registration. This first page prompts for the personal information of the user. Note that the information on this page is all that most authentication systems require. Because the registration process can be lengthy, our prototype allows the user to partially register their account so they don't have to complete the entire registration in one sitting. Furthermore, this allows the system to be configured to use varying levels of security for different users or user groups. Next, the user must enter their cellular information in order to bind their cellular phone to their account. To confirm the phone number is valid, an SMS message containing a 6-digit code will be sent to the phone. The user then enters and submits the code. To set up the time-based one-time password modality, we use a mobile app to scan the QR code that was generated by the server and contains a shared secret key. The mobile app automatically generates a new code every 30 seconds. The user must enter and submit the displayed code within the 30-second window. For our biometric algorithms, our system uses machine learning techniques to better learn and identify the users. As more samples are given, the more accurate it becomes. Now we begin registering biometric modalities. Here, the keystroke timing information is recorded. You can see these times posted on the screen, but these are not normally visible to the user. Here, a connected webcam captures 10 facial images, which are then sent to the server for feature extraction. On this page, we record the user's voice speaking the phrase multi-factor authentication in order to build an audio biometric profile for the user. For all biometrics, we take several recordings in order to develop a more robust model for the user. Lastly, a fingerprint scanner is used to obtain 3 fingerprint images from the user. This final page is an under-the-hood view of the sensors being read to the screen. Normally, it isn't visible, but it shows the ambient light and sound conditions for this room. These are used in order to adaptively influence the modalities that will be selected during the authentication phase. To gather the surrounding conditions, we use an Arduino Mega microcontroller with light and sound sensors fitted in a customized 3D printed case. To begin authentication, we return to the welcome screen. This time, when the user enters their email address, a selection of modalities are given to be used to authenticate to the system. For the first authentication attempt, face recognition, keystroke analysis, and password were the modalities selected by the system. For the authentication phase, fewer samples are required for extraction than were collected in the registration phase. For the second authentication attempt, the system has selected the fingerprint and passphrase modalities. It is worth noting that multiple algorithms may be used for each modality during a single authentication attempt. In this case, the fingerprint provided is being processed through 2 algorithms for authentication. Coupled with passphrase, this brings us to 3 modalities actually being authenticated, even though only 2 were prompted. For the final authentication attempt, fingerprint, keystroke, and one-time password must be used to authenticate. The server's just-in-time modality selection approach uses a genetic algorithm. This algorithm generates the best selection of modalities for the user's operating environment. This concludes our demonstration. We are continuing development by preparing our authentication software for deployment as a cloud-based service, developing native applications for mobile devices, and to adopt a more modern web-based interface. Thank you for watching. If you would like more information, please contact us or visit our webpage.